Chapter 9, problem 37. If a 25 kilogram mass is if 25 kilograms is the maximum mass m that a person can hold in a hand when their arm is positioned with a 105-degree angle at the elbow, as shown in Figure 9-74, what is the maximum force F max that the biceps muscle exerts on the forearm? Assume the forearm and hand have a total mass of 2 kilograms with a center of gravity that is 15 centimeters from the elbow, and that the bicep muscle attaches 5 centimeters from the elbow. Alright, so excuse my crude painting of the arm, but this will have to do for now. Just focus mainly on the free body diagram, or the point mass, the force diagram. That's where the important stuff is, but it was just to help me kind of understand the problem a little bit. But yeah, we're looking for F max here, and so we have, just going from left to right, we have F max pointing in the northwest direction at an angle of 105 degrees. So we're looking for this force. Next on the line is a little mg. This is just the center of gravity, 15 centimeters away from the elbow. And then the big mg, we have the weight at the end of the hand. So what can we do with all this to find F max? Well, in this chapter, we deal a lot with equilibrium, and essentially, since the hand is not moving, the system is in equilibrium, which means there's no angular acceleration, there's no linear acceleration, and this lets us say that the sum of the forces of the system and the sum of the torques of the system are 0. And with that, we can choose a pivot point and then begin to do some calculations and find out some things that we may need to know. So if we choose the pivot point to be about the elbow joint, so it's going to be the farthest point right here, then we'll have a torque here, we'll have a torque here, and we'll have a torque here, right? Forces are very clear. We'll have a y component for this part and an x component for this part, but that's for a different part. Just focusing on the torques right now, we have all the distances, all the mass, we have all the information we need about the problem to find F max. So let's, just thinking about it real quick before we go to the next page. Normally we say counterclockwise torques are positive, but in this case, let's just have this clockwise. So clockwise torques are positive today. And essentially this is going to tell us that anything in the direction of this is going to be positive, anything against this direction is negative. And as you can see from the diagram, F max is going away from our positive direction, and both of the mg terms are going with our positive. So both mg terms should be positive, and we should have one negative F max term. And this is exactly what we see. So we have, excuse the centimeters, I wrote centimeters first, but it's really, you can't multiply something that's g. If g is 9.8 meters per second squared, you cannot multiply it by a centimeter. It must be in meters for it to be correct. So just wanted to fix that. But it is technically correct that it is 15 centimeters and 0.15 meters are the same thing. But yeah, we have both mg terms positive, F max term negative, and we just want to do algebra here. Add F max and its stuff onto the left side, divide by 0.05 meters, and also by sine of 105. Sorry if you can't tell, this is a parentheses, close parentheses. Then you just divide that, and you should get about 1800 newtons. It's 1836 to be exact, but you should expect something around there, depending on if you use 9.8, 9.81,